Hello everyone, we're back with a video to discuss some ASMOPSS questions. All right, so let's get started. Question 1. Two teams, each consist of 5 runners, compete in a running competition. The runner who finishes on the nth place gets n points. The team with the least total number of points won. Every runner finished on a different place. How many different total numbers of points could the winner team have? Right, so we've got some key information here that it says when you finish on the nth place, you get the n points. So let's say somebody finishes first, then the team gets 1 point. Okay, so that just makes sense that a team wins if the team has less number of points compared to the other team. Right? So now we know that there are 5 runners in each teams, which means there are 10 runners in total. So we have to know how many points there are to be obtained. So from 1 plus 2 plus 3 until 10, there are a total of, you can use the sum consecutive numbers. So 1 plus 10, that's 11, times 10 out of 2. Or divided by 2. So that means the total number of points is 55. For a team to have less than the other team, half of 55 is equal to 27.5. That means the team has to have less than 27.5. So we are going to look for some combinations of numbers to get a sum less than 27.5. So with that in mind, we can, of course, try with the least possible points first. Let's say the team won the top 5 places. So the total point that this team earns is only 15. So surely this team wins, right? Or 1 plus 2 plus 2 plus 4 and then plus 6. Then that's going to add 1 more to it. And we can keep changing that to this. So we'll get 17 points, 18 points, 19 points, and 20 points. So let's try to find out if we can have 21 points in total, because we are looking for different total numbers of points. All right. So if we add 2 to 3 to 4 to 5 to 7, let's say to 6 first. Okay, this is 10 plus 10, it's 20. So we don't count this because we have already got a total point of 20. So now let's keep the 6. That means we should go with 7. So that is 21. Then if we change it to 8, 9, and 10, that's going to be 1 more for each. So 22, 23, 24. Now, is it possible to get 25, 26, and 27? Remember, 27.5 is the maximum we may get. Okay. Then if we change the first position into 3, 4, 5, 6, and 7, then we obtain a total point of 25. Okay, 7 plus 3, 10, 6 plus 4, 10, so 25. And then we can change that to 8, 9, 10. Then that's going to be 26, 27. But when you add 10 to it, it is 28. So this doesn't count. Remember, it has to be less than 27.5. So how many different total numbers have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So the answer is D. All right. Now let's go to question 2. An 8-digit number 20, 20, 20, x, y is divisible by 12. What is the smallest possible 2-digit number x, y among the following choices? For a number to be divisible by 12, it has to be divisible by both 3 and 4. So we have to apply the divisibility rule by 3 and by 4. So for a number to be divisible by 3, the sum of the digits must be divisible by 3. So that means 2 plus 0 plus 2 plus 0 plus 2 plus 0 plus x plus y must be divisible by 3. Then the 20, 20, 20, if you add all the digits, then the sum is 6. That means when you add x and y to it, it has to be divisible by 3. And the smallest number, the smallest two-digit number, x, y, is going to be 1, 2, which is 12. 600 and, the sum is 9. So the number that it forms is 20, 20, 20, and 12. Now, is this number is also divisible by 4? So the divisibility rule by 4 says that the last two digits of the number must be divisible by 4. So the last two digits here is equal to 12. Is 12 divisible by 4? The answer is yes. So the smallest number x, y that can be formed is 12. Right? Now let's go to the last question, number 3. Consider the following sum, 125,678 plus all the numbers there. It is known that the sum is the product of n different prime numbers. What is the value of n? So the question here asks us to get how many prime numbers are the factors of the sum of that number. So first of all, we have to get the sum. Okay, we can do simple addition, and after doing simple addition, we will know the total, right? The sum. So let's add this. 8 plus 1 plus 2 plus 5 plus 6 plus 7. So without having to do the vertical working, we can simply add that in our head because it's just addition. So 8 plus 1 is 9, plus 2, 11, 16, 22, 29. So now we've got 9 and a 2 in the tens place. 2 plus 7 is 9, 17, 18, 20, 25, 31. So now we've got a 3 in the hundreds place. Plus 6 is 9, 16, 24, 25, 27, 32. Then a 3. 3 plus 5 is 8, 14, 21, 29, 30, 32. Another 2 and another 3. 3 plus 2 is 5, 10, 16, 23, 31, 32. Another 2 and another 3. 3 plus 1 is 4, 6, 11, 17, 24, and 32. So this is the sum of the number, and now we have to find the prime factor. So we can always do what we call prime factorization by using factor 3. So the smallest prime number is 2, but we know that this number is not divisible by 2 because it is an odd number, right? So we have to divide this by 3. Perform the simple division. Then if we divide this by 3, we will get 1,074,073. Right? Then the next prime number of the 3 is 5, but again, this number is not divisible by 5. So we divide it by the next prime number, which is 7. And that is equal to 153,439. The next prime number is 11. So we can divide this by 11. So that is equal to 13,949. And after 11, the next prime number is 13. So we can divide this by 13, and that's equal to 1,073. After 13, the next prime number is 17. But then 1,073 is not divisible by 17. So after 17, it's 19. Again, that number is not divisible by 19. And the next number is 23. So again, this number is not divisible by 23. And after 23, the next prime number is 29. Then when you divide this by 29, then we get the next prime number, which is 37. So basically, 3,222,219 is equal to 3 times 7 times 11 times 13 times 29 times 37, which means there are 1, 2, 3, 4, 5, 6 prime numbers as the factor. All right. So those are all the solutions of these 3 questions, and I'll see you in the next video. Bye-bye.